think last time we introduced a bit of like the tedge flows, name pending, which allows users to basically create your own custom mapping definitions. So not relying on, the Azure mapper or Cumulocity mapper or something, and then basically doing your own transformations. So you can integrate these with existing clouds. So the Azure and AWS are already done, and we're working on the Cumulocity, which hopefully should be merged within a week. But you can go beyond that. So you can actually use these flows to actually define your own mapping rules for a new cloud. So in this kind of effort to prove that, do we have all the right mechanics within the tedge flows that we can offer to our customers to, write solutions such as this, we decided to take the Thingsboard as an example, saying, what would it take to write our own custom Thingsboard cloud mapper purely using the tedge flows? So that's what Rena will be presenting. So this is purely focused on the mapping. So I'm not talking about the cloud connection. That's going to be part of a different feature. So for example, how do you establish the connection to the cloud? So at the moment, we're just doing this manually. This will definitely be nicer, but it's kind of not directly related to the tedge flows, because essentially the tedge flows is just about input and output messages, nothing more, nothing about MQT bridge connections or anything. So that will be covered. We don't want to focus on that point. So you can just assume that it exists. So we'll give a bit of overview that, so it's more based as an example to, stress test what flows can do. But in the future, we can imagine this being a community project that we put out into a separate repository that people can also commit to or fork or whatever, because it could be an optional component, especially if you've integrated thin-edge on your device and you're looking, a customer of yours comes along and going, that's great, I can do device management with Cumulocity, but I would also like to publish telemetry data to my cloud, and I'm already using Thingsboard. So this kind of enables you to be more flexible with your customers, to also then support their requirements, which you might not always be in control of. So we'll show a fully fledged kind of mapper that will publish telemetry data, and also then do command-based interactions. So sending something to the cloud, down to the device, doing something, sending the response back. So those are the real two fundamental elements of any mapper. So I'll then hand over to Rena to actually go through all the details and kind of show it in action.
Yes, thanks, Ruben, for the introduction. So I'm going to start my demo, and let me share my screen. If the font size is too small, please tell me now. Okay, probably fine. Then, yes, this demo is about the integration thin-edge and Thingsboard cloud. So this shows actually a good example that the thin-edge is cloud agnostic. So we support not only Cumulocity, but also other cloud. The Thingsboard, what I'm using here is the community edition. This is an open source project, and you can deploy it on your Docker container, or they also provide apt package. So actually, so in this setup, I install apt package on my Raspberry Pi 5. So that means actually this Thingsboard is running on my Raspberry Pi on my local network. That's why its IP address looks like that. Yeah. So the Thingsboard, the main concept is the device connected directly to the cloud. It's called gateway. So you need to have this its gateway flag, and all others like child devices, services won't have this is gateway, and this separation is important because they offer different API for the gateway device that with direct connection and other devices. Yep. Okay. Then so my gateway device is already registered here, and now I can show you a quick demo. First demo, like sending telemetry. So yeah, I forgot to say. So also Thingsboard, there's two different categories for the data. So one is telemetry. This one is more time sensitive data, and attributes is more like persistent. So that's why. So I created the mapping rules that measurements, alarm, events on ThingEdge, it goes to telemetry, and the twin will go to attributes. Okay, and then first I can just run here the tedge MQTT sub. So this is my test container for the demo, and then tedge MQTT sub. This is a normal ThingEdge topic for measurement. Name. What is good in the demo? Yeah. Then humidity. Okay. Yeah. Then, yeah, you can see that I published normal the ThingEdge topic for measurement, and you see another message now published. This one is converted by TedgeFlow, so to Thingsboard data model there. Then here you can see this one. Okay. Yeah, here. Exactly. This is because I sent the type demo, and then key was humidity and the value 40. Now this one's recorded. So yeah, it looks like a magic. And then now I'm going to explain what happens behind the scene. Okay. Yeah, this is how this telemetry twins the data moves. So first part that I have done, publish to measurement topic. Yeah, here this part, and then this one goes to tedge flows, that is mapper, and then this flows transform to Thingsboard format, and then this one published to this TB-me telemetry. Yeah. And actually there is a bridge configuration. So now I'm using a mosquito bridge. And then this mosquito bridge configuration change the topic, maps the topic from a local topic to remote topic. So this is remote topic is actually, so if you go to Thingsboard documentation, you see you have to publish to this topic for telemetry for the gateway device. And then this message now went to Thingsboard, and then now telemetry, as you see. Yeah. Then probably also I can quickly show what the mosquito bridge configuration I have. So this connection part just ignore, but I have this kind of mapping rule. So this will be feasible also from ThingEdge in the future. So for example, this one I use telemetry now, then telemetry going out is TB-me prefix, the local prefix changed to V1 devices me prefix for the remote. Yeah. So then I can do also as a type, not only measurement. For example, okay. I'm doing this one here. Oh, too big. Yeah, I think then you can see here. Oh no. Okay, forget. Okay, then create alarm. Demo. Something. Yeah. Humidity is okay. Now it's alarm topic. And the alarm for the alarm, you need a status. Yeah. Then you can see actually now it gets active, and okay, now I can send that. Then to clear alarm, empty payload. This is in ThinEdge contract. Yeah. Last one is the event for telemetry. Event, maybe enter event text left in. Yeah. So here you see event enter text logged in. So this is for telemetry. So now maybe you are wondering why it has event alarm such prefix. This is a nice part of tedge flow. This is actually you can configure. This is a custom configuration. So there's a toml file for flow, and then these value alarm events. This one comes from here. Yeah. To distinguish if it is measurement or alarm or event. Okay.
Yeah, so to contextualize that, so different clouds will have different modeling for different data types. So just Cumulosity has a quite extensive types because it differentiates between measurements and events, whereas Thingsboard generally doesn't. So it means you have to kind of do the modeling from the ThinEdge kind of data format to the Thingsboard, and so that will always look different for everyone if it doesn't handle the one-to-one mappings. So having this kind of level of configuration in the flows is very important, so people can kind of decide what works for them. Or if they don't want a prefix, then don't add a prefix. That's also fine, or add it in a type. But the key is being flexible to these different requirements that different clouds have. So hopefully that kind of shows the power of the tedge flows, that you can kind of implement all of these kind of differences in the cloud.
Yep. Yeah, thanks, Ruben. Then next, how the twin converts to Thingsboard format attributes. So then I publish twin topic, twin demo, then software, things. Yeah. So now you see this, then this one actually went to attributes, demo, software, and value ThinEdge. And till now, so everything I created against the gateway device. But of course, this flow supports child device conversion as well. Now, I can create a new child device. Child one, and type child device, and current. This is all a ThinEdge contract, what I'm writing now. Device. Can add a little bit more.
And they should be published with the retained messages as well.
Yeah. True. Thanks. Version 0.1. Yeah. So this gateway connect is the Thingsboard API to create a new child device. So then this new registration message now converts to Thingsboard new creation for child device message, and also additional field. This parent version is the now also published as attributes there. Then we can check here. Okay, reload. This one, yeah, child one, what I did now. Then we send the parent device. Yeah, okay. Yeah, this is actually yesterday I created. That's why you can see already some measurements. I should have used maybe new name, but this is why I added the version there, and then this one is updated. And so, yeah, one remarkable thing. So, what is the proper part of the flow? What I like is you can test how the message converts by flow. So before publishing it, and this is quite easy. Like tedge flows run or test.
Test.
Test. Test. Yeah, and then it's quite similar what you do for MQTT pub, but then you see, yeah, how this actually converted. Yeah.
So that's without sending the message. That's just basically printing the output on standard output.
Yeah. So this is yeah, the feature. I really love it. Yeah, I think this is all for telemetry flow. Also, yeah, interesting part is so which flows you can make, you can define multiple flows. So actually now I have two different flows. One is for measurement, event, alarm, device registration, and the other one dedicated to Thingsboard RPC. Thingsboard RPC is similar to cumulative operation. So like the server creates operation. This is called RPC on Thingsboard context. And then device does something, and the device reports back to cloud. And then this log is this response is logged in the server side. So okay, my first demo was I was using this Thingsboard measurement MEA flow. Then I'm going to switch to the Thingsboard RPC flow for the demo. Okay, this one is already run. Better to show first. So RPC, you can create from their dashboard function. And then I'm using this debug terminal, and you need to define the method. So method name is like operation name in Cumulosity, and the command name in ThingEdge. So get tedge version. And as you get a reply from things. So now it says the tedge version is 1.7.2 from the main branch version. Then it's like magic. So of course I will explain what happens there. So this is very nice. So this is actually combination with the tedge flows and workflow feature existing workflow feature on ThingEdge. So first, the RPC request comes from Thingsboard, and then tedge flows convert that request to ThingEdge commands format and status in it, of course, because this is the first one. And then this part executing successfully is actually coming from workflow. So I have already workflow definition on my device. This is tedge. So etc tedge operations. I have get tedge version toml. This is very simple flow. It was get tedge version toml, then operation get tedge version. So because this is the Thingsboard method, and then this one changed to command, and this workflow reacts to this command type that is here operation, and then this one executes a script that gets the tedge version, actually behind the scene landing on the tedge dashes version, and then change to successful.
Yeah, so just one thing to point out with the tedge agent workflows. So that actual workflow definition, get tedge version, that is actually cloud agnostic. That has no idea about what cloud requested it. It just receives its own kind of command and says, okay, someone's requested an operation or command called get tedge version. It'll do its work, present the result of that, and then it's the tedge flow, which is then picking that up and then translating it to the required cloud status message. So it's basically, because we're really pushing this cloud agnostic kind of like design, is that if you want to then implement this kind of operation flow within Comolocity, you can do that. Like, you don't need to change that get tedge version TOML file because that is cloud agnostic. You just need to do a mapping for Comolocity to then, how do I know I need to map that to that kind of local agnostic command? So that might sound a little bit complicated, but it's a very powerful feature that we can encourage, because if people want to not getting locked into kind of one cloud all the time, especially if you have customers which have different requirements to do different kind of actions, then you can kind of control what is processed by which cloud.
Yeah. I can show the last is a diagram. Probably it's better to understand how it works. So yeah, this diagram is a bit complicated, but what happens from cloud side, we created RPC from this dashboard debug terminal, and this one was remotely published. This VM devices me RPC request topic that is Thingsboard context. But because we have a mosquito bridge, this will be replaced by a ThinEdge built-in bridge, but as of a mosquito bridge. So this one maps remote topic to local topic, and that's why local topic becomes actually TV me server RPC request one. So as you see the right side from the tedge MQTT sub, and then tedge flows subscribes on that topic, and then tedge flows converts the message to CMD topic. This is a ThenEdge contract, and then tedge workflow gets triggered because tedge flow knows for the get tedge version operation, it needs to react, and then it does. It processes operation for this get tedge version, and then the final message going to tedge flows, and the tedge flows converts from ThenEdge contract CMD topic format to local Thingsboard topic TVMe server RPC. You see here CB server RPC response, and then mosquito bridge again maps back to remote Thingsboard contract topic via devices me RPC response, and then Thingsboard understands, okay, the response comes to Thingsboard. So that's why, so here you see response. Yeah, I think that's all. Yeah, I showed both MEA flow and the RPC flow.
Yeah, cool. Yeah, I was about to say we can open up for questions because it's quite a big topic. So Mario, please.
Cool. Thanks. I like the demo. Actually, it's a nice feature. To be honest, I was a bit confused on if tedge flows and tedge workflows are the same, naming wise. Sound similar, but I get that tedge flows basically is a bit of a replacement for like the custom mappers that we've previously had, I assume.
There were no custom mappers, but yeah, for a mapping thing that someone wrote themselves, yes.
Okay. I'm not sure if I oversaw it, like, but how is the device registration initialization handled there? Or is there something specifically for tedge?
Yeah, that is nothing for this kind of round. So that will be part of basically we want to open up how to define a bridge definition. So the actual registration could be, let's say, like the registration messages could be handled there, but the actual kind of connection handling, we're still integrating that, but that is kind of decoupled, let's say, from this kind of like mapping logic. So that's akin to like, a tedge connect kind of thing. So that will be handled separately, but we envisage that, yes, we will have some kind of work like set up to enable that. But it could be that also for definitely generic brokers, maybe there's nothing that we can really abstract. So you might need to create a file at the beginning, add your credentials, because all the different kind of clouds do it slightly different. So there might be some kind of manual configuration in some aspects, but the idea is that we want to enable a kind of a bridge definition file, which also has like a connection, how do I connect to that kind of external broker that people can then use to connect to whatever clouds. So that would open up not only Thingsboard, but like Event Grid from Azure and all these. If it's, as long as it's an MQT compliant broker, then it should be able to connect to.
Okay, so how does it work with Thingsboard? It's like you have to register your device on the Thingsboard first, or does this automatically happen when you
just like
the first
you
message?
enter basically, I think you register the ID and then you get a connection token that uses that the bridge needs for authentication against that endpoint. You can do certificates as well. So if you are using kind of like even the Comvelocity CA, you could kind of input, I'm not sure whether it's a free feature of Thingsboard or not, whether you can just upload a root certificate. So the CA certificate from Comvelocity, put that in. It can't issue certificates, but it can trust things which are connecting from a certificate issued by a trusted CA, then that could work. But that's a little bit dependent on the actual cloud. So in Thingsboard, you can do like a token base, which is like more or less username, password. But I think they also support certificates.
Okay, thanks.
Yeah, but the important thing is the connection, how it connects is a little bit decoupled from once I'm connected, what do I do? But yeah, part of the full end-to-end feature is definitely you need both. But at this point in time, we're just stress testing the flow design to see if everything works. Does it have all the mechanisms? And it just shows that sometimes the clouds have different kind of complexities, and we're able to kind of implement stuff. So this is all implemented in JavaScript. And also, Rena, I'm guessing what, under 200 lines, and that's not that's pretty printed. So it's also not like super complex JavaScript as well. It's mostly just mapping different messages, even less. So the RPC is 49 lines with spaces. And
yeah, I mean, like maybe one.
Yeah, okay, it's
less than 200 in total.
Yeah.
This is.
And that means it's also architecture agnostic. So you don't have to worry about CPU architectures. I have to build different ones for different devices. It's the same thing. It's just JavaScript using our lightweight kind of QuickJS runtime to execute all of this. So it's very lightweight packaging and memory usage. So you can also run this on really kind of resource-constrained devices. And then you can commit this. We have like examples that you can then compile if you want to write this in TypeScript, compile down to JavaScript. That's all possible. So it adds quite nice. You can actually do something very quickly to then add a mapper. Most of the challenge is just understanding the cloud you're connecting to, not really how do I do that within Edge. So it's more just how do I model that in the respective clouds, which is probably the most challenging bit. Especially for all the Comvelocity kind of employees, we're kind of used to that data model, and then Thingsboard does something slightly different. Especially with their alarm handling, they basically say devices don't create alarms, or at least this is my interpretation. Correct me if I'm wrong. They don't expect devices to create alarms.
Right.
They expect a server to react on data coming from the device to translate that into an alarm. So they're kind of delegating, going, the device is not smart enough to determine what's an alarm. You can create I don't know, like some server-side logic, which then convert a telemetry data point or an event or whatever to an alarm. So it's slightly different concepts, but the full thing that we're really proud of was that this is the full connection. So, pushing data out and reacting to operations, which is no mean feat, and this is all done, in a very small package.
Mm-hmm. So the Quick.js runtime you mentioned, like, is this part already of tedge, or do you need to use?
Yeah, so it's basically with the 1.7, it's the engine is actually included, but it's not used. So with the next major release, or like the 1.8, because it will be a non-breaking change, it will include, like, we will basically integrate flows into every mapper. We're also changing our logic so that most of the mapping rules are actually done by the flow itself, and not done how they used to be done within like pure code. So you can actually change. The idea is you can also change, if you're not happy with common velocity mapping, you can edit it, which is something that wasn't previously possible. Or you can create your own kind of mapper which runs its own flows or whatever to do whatever mapping you want. So it's part of a larger strategy to basically make it more customizable and reduce the amount of code that you need to write by simplifying the deployment of it, being architecture agnostic, lightweight, so you don't need to worry about connecting to the MQ broker, because that's also not trivial. So it kind of simplifies all these things, and in the end, you can just basically do some simple JavaScript things just to do mappings, whilst taking advantage of the full mapping, like the JavaScript power that you can do, array iterations very easily and stuff like that. Yeah, and you can also do like basic analytics, like Roshan said, filtering, a lot of different things. So we're trying to, in the demos, slowly like give more and more insights on what's possible. If you're interested, Rena, could you post the examples repository just to have like a look at some of our example projects there? But yeah, this will be in the next major release.
Okay, cool. Yeah, these examples will have maybe also like distinguishing of what would be like a flow and what would be like a workflow potentially. Yeah. Thanks.
Cool. Okay, then thanks, Rena, for presenting.